All right, y'all, so we're going to go through the putting it all together worksheet. I'm going to try to talk through as much as I can with you. Okay, now you'll need to use your own periodic table here. I'm not going to be showing my periodic table, but I will talk about it. And if you need to pause the video to find certain elements, then you can do so. All right, so here we go. The first question here is, what is the difference between an atom and a molecule? All right, so hopefully this is pretty straightforward. We know that an atom is made up of a single particle, right? It's got protons and neutrons in the middle, and it's got electrons going out on the outside most of the time. A molecule is one or more atoms bonded together. Okay, so they're basically the same, except a molecule has to be made up of more than one atom that's bonded together. Okay, that's not too bad. Let's look at the next one. We're going to compare and contrast elements, compounds, and mixtures. All right, well, elements, compounds, and mixtures, if I had to compare them, I would probably say that they are all made of atoms, right? Now, compounds and mixtures are both made of more than one type. Of atom. Okay? Now, elements, you can have more than one atom, but they have to be of the same type. So here's where the contrast is going to come in. So an element is only made up of one type of atom. Okay, one type of atom. Now, that could be a single, for example, a single silver atom, right? It could be a couple of silver atoms, or it could be, like in the case of Cl2, it could be two or more that are bonded together, but it can only be one type of atom, right? So this would be silver element, this would be chlorine element, okay? But you can't have those two together because that would be two different types of atoms. A compound is when you bond two different types of atoms together. Two or more different atoms, different types of atoms bonded together. Last of all, a mixture is two or more different atoms or molecules that are not bonded together. All right, like if I had water and sodium chloride that were all mixed together, that would be a mixture because the water is one type of molecule and the sodium chloride would be a different type, and that's all mixed together. Okay, water would be a compound because it's hydrogen and oxygen, and sodium chloride would also be a compound because it's sodium and chlorine. All right, so there we go. Let's go ahead and look at this next question. So here they want us to just look at some of these and try to identify what they are, okay? So first thing it wants to do is circle the elements. So elements are found in the periodic table. And so if you look at your periodic table, you should be able to find out which of these are on there, right? Table salt is not an element. It's not on there. You can tell that zinc sulfate has more than one element in it, so that's not an element. Now hydrogen, that's the very first element in the first column, so we're going to go ahead and circle that one. Hydrogen gas, remember, is H2 because it's one of our diatomic molecules. And so it is a molecule, but it is only one element. So we consider that to be an element. Okay? Neon is also one of our elements. If you look over on the right-hand side of your periodic table of elements, neon is right below helium. Okay, now neon is not a diatomic molecule. It's not one of our Brinkelhoff, right? Brinklhof. So it's not one of those. So it's just neon, but it is an element. Okay, and so we're going to circle that one. Water is not an element, right? Water is made up of both hydrogen and oxygen. Sugar is not an element. Sugar actually has carbon and hydrogen and oxygen in it. Okay? You don't necessarily need to know exactly how many carbons, how many hydrogens. There's actually different types of sugars, but pretty much all of them have carbon, hydrogen, oxygen in them. And then we've got magnesium metal. Okay, magnesium is in the second column. It's right under beryllium. So magnesium will also be an element. All right? Now, so that's all. I went through all of them. Air is not an element. It's made up of lots of different things. So next is put a box around the mixtures. Okay, well, it turns out that the only mixture we have here is air, right? Air is made up of oxygen. It's made up of carbon dioxide. It's made up of nitrogen. There's lots of stuff in the air that's all mixed together. Table salt is only sodium and chlorine, so that's not a mixture. Zinc sulfate is only one type of molecule. All of those are bonded together, so that would not be considered a mixture. Hydrogen gas, only hydrogen, only neon. Water is only water molecules, H2O, so not a mixture of different types of molecules. And sugar, again, is also just one. In a specific type of sugar, there would only be one type of molecule there. So therefore, the only mixture then would be air. Okay? Next, we're going to put a star next to the molecules. So anything that has more than one atom bonded together. So table salt has two elements bonded together there. The zinc sulfate has three different elements there. Magnesium metal is not one of our diatomics, so that would just be Mg, so that's not going to be a star. Sugar has carbon, hydrogen, and oxygen bonded together, so that's a molecule. Water is also a molecule because it's H2O. Neon is not. That's not one of our diatomics, so neon is just one single atom. You'll have a lot of them there, but they're not bonded together. And then, of course, hydrogen gas is a molecule because that is one of our diatomic molecules. Now, each of the things in air, each of those would be considered a molecule. Air itself isn't really, but it is made up of molecules. So up to you whether you want to mark those or not. Doesn't matter. All right, the last thing is it wants us to highlight the compounds. So compounds are anything made up of more than one type of atom. So table salt is made up of sodium and chloride, so that would be a compound. Zinc sulfate is made up of zinc and sulfur and oxygen, so that's a compound. Magnesium is only magnesium, so that's not a compound. Sugar is made up of three different types of atoms, so that's a compound. Water is made up of hydrogen and oxygen, so that's a compound. Neon and hydrogen are both elemental, so they are not. Now, if we look at air, carbon dioxide is a compound. Oxygen and nitrogen are not. Those are technically elements. All right? So, you should notice that pretty much every individual type of thing is either a compound because it's made of more than one type of atom, or it's an element, meaning it's only made up of one. Okay? But air, being a mixture, is not an element or a compound, right? It's made up of elements and compounds. Okay? So, hopefully that was helpful for the first three, getting used to mixtures, elements, compounds, and molecules. Let's move on to the next page. All right. We got one more thing here where we're going to try to identify elements, compounds, etc. And so first it asks us to find the pure element, so that would be made up of only one type of atom, so that would be C here. Okay. Then we want a mixture of elements, and so that means we have a mixture, that means we have different things. They're elements, and so only one type at a time. They're not bonded together. It's not a compound, but it is a mixture of more than one type, so that would be E here, would be a mixture of elements. Okay? If we look at a pure compound would be made up of only one type of compound. And so if you look at A, you'll see that this is black, white, black, and this one is white, black, white. And so those are two different types of molecules there. And so they're two different compounds. So the pure compound would be B, which is made up of only one, the white, black, white, white, black, white, white, black, white, right there. So that's going to be our pure compound, and A is going to be the mixture of compounds because I have two different types of compounds that are mixed together there. All right? Then the last one, of course, is going to be a compound and an element. So you've got a compound where you got the black and the white together, and then you have the element, which are those two right there. So we've got D. Okay, so that wasn't too bad. Let's have a look at number 5. Okay, number 5 says, for each pair of elements or polyatomic ions, write the balanced ionic formula and then name the compound. All right, so this one wants us to write the formula for what happens if we put that sodium and nitrogen together, and then it also wants us to name it. All right, so the first thing I'm going to do is I'm going to find each of these elements in the periodic table. So sodium is in the first column of the periodic table. It's the third one down. The first column, remember, they have one valence electron. They have one extra electron in the outer shell. And so it tries to give that electron away. And when it gives that negative away, the sodium becomes +1. Now nitrogen is over on the right side. It's actually the third one from the end, right? Remember the column with helium, that has 8 electrons. It's full. The valence electron, the shell, the outer shell is full. And so as we go to the left, fluorine would have 7 valence electrons. Oxygen would have 6, and nitrogen would have 5. So nitrogen has 5 valence electrons, 5 electrons on the outside, and therefore in order to get 8, it wants to gain 3 more electrons. So the nitrogen is going to be -3. So when I put sodium and nitrogen together, I can't just put them together because the sodium is +1 and the nitrogen is -3. So the sodium will say, here, you can have one of my electrons, and the nitrogen is going to say, that's not enough. I need more. I need 3. So in order to get 3 electrons, I need this to be 3 sodiums. That way the first one can give him an electron, the second one can give him an electron, and the third one can also pass over an electron. So each one of those 3 sodiums gives 1 electron to the nitrogen. So each one of those sodiums is happy because they've each given up 1, and the nitrogen is happy because he has gained 3. And so the final formula here would be Na3N, and we would call that sodium nitride. Okay, and you'll remember we just changed the end to be "ide." And that's it. All right, let's have a look at the next one. So the next one is copper 2. So remember I said that copper, anything in the transition metals, copper is number 29. You can find it there. Copper is +2. That's what the 2 means, is that it's going to be a +2. All right, now bromine is over on the right-hand side. It's underneath fluorine. Okay, that next to last column has 7 valence electrons, which means it wants 1 extra electron. So when it gets that, it's going to be -1. And so now we've got copper, which is +2, and we've got bromine, which is -1. And you'll notice that copper wants to give away 2 electrons. It can give 1 to this bromine, but it wants to give away another one. And so I'm going to need a second bromine there. By having a second bromine, then copper can give its second electron away as well. So now 2 bromines are gaining an extra electron. They're both happy. This is the ionic formula. So this would be copper. We always name the positive one first. And then instead of bromine, we'll go bromide. Copper bromide. That's it. Okay, next one. We've got calcium and phosphate. So phosphate is one of those polyatomic ions. It's one of those groups that just likes to hang out together. So calcium is the second column over. It's under beryllium. It's number 20. So calcium, since it's in the second column, it has 2 valence electrons, 2 electrons in the outside shell. Now that means it wants to give away those 2 electrons. So when it gives away those 2 electrons, it's going to be a positive 2. The phosphate, you can see already, is -3 here. And so when we put the calcium, which is +2, and the phosphate, which is PO4, which is -3, that's going to be a little bit harder to match up. We need to find the lowest common multiple. I can't just put 2 calciums because then I would need 4 electrons to give away. And so I need to find the lowest number that has both 3 and 2 in it. And so what you should get, hopefully, is 6. So what that means, because calcium is ready to give away 2 electrons, is that calcium is going to need to have 3 of them. So 3 calciums will give away, 3 times 2, they will give away 6 electrons. The phosphate, 3 times 2 is -6. And so now that will be allowed to take the 6 electrons. So I have 3 calciums, each of which are giving away 2 electrons. And I have 2 phosphates, each one which is going to gain 3 electrons. Now, the proper way to write this is Ca3, PO4, 2, just like that. And then this would be considered calcium phosphate. Okay, now the polyatomic ions, you don't need to change the end to "ide." They've already been put in the correct format for when they create the new atoms. Okay, so calcium phosphate is ready. That's it. Okay, the next question asks us to draw a model for a neutral atom that has 12 protons. Now you can do this however you want, but I'm going to go ahead and put 12 protons in the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, looking at my table of elements, I can tell that 12 protons is magnesium. All right, so magnesium is the second column, which means it should have 2 valence electrons. Now, 12 protons, in order for it to be neutral, then it should have 12 electrons. Remember, the first shell will hold 2. The next shell will hold 1, 2, 3, 4, 5, 6, 7, 8. So I've got 2 plus 8, that's 10. So I need 2 more to make 12. So now I've got 12, and notice that 12 is exactly what I needed. I now have 2 valence electrons. Those are the 2 that the magnesium would want to give away. But for now, we want it to be neutral, and so 12 negative electrons and 12 positive protons. All right? Nice job. We're doing all right. Let's go on to the next one. Here we go. So this is a continuation of the previous question. What element is represented by the model you drew? Well, we already looked that up, right? The 12 protons was magnesium, all right? And Mg is fine. We all know that Mg is magnesium because it's in our table. What would be the charge of this atom when it creates an ion? Okay, so that's what is it trying to become, right? Now remember, magnesium had 2 valence electrons, so it will get rid of those because that's easier than trying to fill up with 8 of them, okay? So the magnesium will give away 2 electrons, which means what will its charge be if it gives away 2 negatives? Well, remember before it had 12 negatives and 12 positives? Well, if it gives away 2 negatives, then it will only have 10 negatives and 12 positives, which means that the charge will be positive 2, just like what we've been talking about, okay? If this atom were to create an ionic bond with one other atom, what are 2 possible elements that it could join with? So here's the key, is it says one other atom. So I need to find something. Magnesium wants to give away 2 electrons. I need to find a type of element that wants to take 2 electrons. And so if you remember in our periodic table of elements, the very far column on the right, the one over on the far right, that one is, those have 8 valence electrons. The next column over, those have 7 valence electrons. The next column over, that has 6. So those are the ones that want 2 more electrons. All right? So therefore, anything in that 6th column will work. So that column has oxygen, it has sulfur, it has selenium, okay? Anything in that column will work, okay? It asks for 2 possibilities. I gave 3. Anything in that column should work out, okay? All right, moving on. Letter E, if this atom were to create an ionic bond with 2 atoms of another element, name 2 elements it could join with. Okay, so again, it wants to give away 2 electrons. So if I'm going to combine with 2 atoms, then what that means is that each of those atoms needs to accept 1 electron. That way, one will accept one, the other will accept the other, so I still give away 2 electrons. And so remember, the 7th column there are the ones with 7 valence electrons, so they will accept 1. They're going to try to steal 1. And so that's everything from fluorine to chlorine to bromine to iodine, right? Now, really, it is just those. This one really should only be those 3 because those are the only ones that are non-metals. We'll talk more about that in class next time. All right? Okay, that's the end of that question. Let's move on to number 7. So number 7 says, find the following table elements in your periodic table of elements. State how many protons, how many electrons are in the outer shell, and then explain what type of ion this element is likely to form and its charge, and then how many neutrons would it likely have. Okay, awesome. So arsenic. I'm looking for arsenic. Arsenic is AS. So AS, I see it, it's right below nitrogen. So from the right, helium's in the first one, then fluorine, then oxygen, and then nitrogen is the next one. So it's right beneath that. So arsenic has 33 protons. I can see that because the arsenic, the AS, has a 33 above it. So it's got 33 protons. Okay? Now, if it's a neutral atom, that means it needs 33 electrons. The next question is how many electrons would be in the outer shell? How many valence electrons does it have? Okay, well, it's in the same column as nitrogen. So the column with helium has 8. The column with fluorine has 7. The column with oxygen has 6. The column with nitrogen has 5. So 5 valence electrons. All right, that's 5 electrons in the outer shell. Okay, letter D, explain what type of ion this element is likely to form. Well, it has 5 valence electrons, which means that it wants to gain 3. So it will likely form a -3 ion. And the reason why is because it wants to gain 3 electrons, so the outer shell will be full. All right. Last of all, E, how many neutrons would it likely have? Well, I'm looking at arsenic, and remember there are 2 numbers on there. One number was the number of protons, that's the 33. The other number is the mass, and the mass is the total of the protons and neutrons together. So when I look at the other number, it's 74.922. So that's pretty close to 75. So I'm going to say there are 75 total protons plus neutrons. Now, we know that there's 33 protons, so if I do 75 equals 33 plus the neutrons, all I have to do is subtract the 33, and I get 42 neutrons. So therefore, it would likely have 42. Now, that's not perfect, right, because this is a little less, because there are different types of isotopes of arsenic, but the most common one would have 42 neutrons. Okay? Very nice. Let's try aluminum. Okay, we can find aluminum. Aluminum is in technically the third column. Remember, we skipped the elements in the middle, the transition elements. So aluminum is the third column. It's right under boron. Okay, the elements in that column have 3 valence electrons. Okay, so I'm already going to know letter C is that there are 3 valence electrons. Okay, as I look at this, I see aluminum is 13, so it has 13 protons and 13 electrons, all right, to make it be neutral. We already said it has 3 valence electrons. You could draw that out if you needed to, but then we go on to explain what type of ion it would be. So 3 valence electrons means that it's probably going to try to get rid of those 3 valence electrons, the 3 extras right there. It's going to try to get rid of those, and if it gets rid of those 3 negatives, then it will be a +3 ion. All right? The last thing is, how many neutrons would it likely have? Well, when I look at aluminum, I see that it is 26.982, so that's about 27. So 27 equals the protons plus the neutrons. There are 13 protons, so 27 equals 13 plus n. Subtract, and I get 14 neutrons. Ta-da! All right, one more on this page. Number 8 asks us to draw a neutral atom with 8 protons and a mass of 17. All right, so 8 protons, so I need 8 protons in the middle. 1, 2, 3, 4, 5, 6, 7, 8. And it has a mass of 17. So if I subtract off the 8 protons, I get 9. So that means it must have 9 neutrons. So I'm going to add in 1, 2, 3, 4, 5, 6, 7, 8, 9 neutrons. So there's my atom. I've got 8 protons, I've got 9 neutrons, and now I need electrons. Well, if it has 8 protons and it is neutral, then I need to include 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 protons, 8 electrons. I'm going to find 8 on my chart. 8 happens to be oxygen. Okay, notice that oxygen is 15.999, which means that the mass of 17 is not the most common isotope, right? It can exist, we just drew it, but it isn't the most common one, all right? Anyway, there you go. Hopefully that's helpful. Let's move on to the next page. All right, so here we took some pictures of some models that I made using the molecular kits. Okay, for each one, we're going to identify whether it's an atom, molecule, compound, element, or mixture. Now, sometimes I might be able to pick more than one of those, so we'll see. In the final column, I want to write the formula for the model. Okay, now I might not be able to do that if there's a lot of them, but we'll do our best, okay? So let's zoom in here. Let's look at the first one. Okay, so the first one, is it an atom? No, I don't have any individual atoms there. Is this a molecule? So technically, each one of these is a molecule, right? So as I look at it, this is a molecule, this is a molecule, this is a molecule, but they're all different types of molecules. So I'm not going to check that one off. I'm going to say, no, that's not really a molecule. Is it a compound? Well, it is made up of compounds, but as a whole, it really isn't a compound. It's definitely not an element because I guess some of them are, right? So this is an element. It's made up of two atoms of the same element. This is an element, that's an element, this is an element, but the other two are not. So I'm going to not check that one off either. The only one I'm going to check off here is mixture. It is a mixture because it does have different types of elements. Now, if I were to name those, okay, I have this one that has two reds, so that would be O2, that would be oxygen. Okay, I have this one that has one red and two whites. So the whites are hydrogen, so that would be H2O. All right, and then I have this one that has two blues, and blue is nitrogen. Nitrogen is also one of our Brinkelhoffs, right? And so that would be N2. So I've named all of them there. Okay, I have several oxygen molecules. I've got a couple of water, and I do have a nitrogen there. Okay, cool. Next up. So the next step, I see 5 yellow ones. It doesn't say what yellow is. Yellow is actually sulfur. And so we can go ahead and mark this one. So this is single atoms, right? There are 5 individual atoms there. It's not a molecule because molecules are made up of more than one atom. Compounds are made up of more than one different type of atom. Element, yes, it is just one element. If it's atoms, it will also be a single element. I guess unless there's 2 different types of atoms there. It's not a mixture, it's only one type. Okay, let's move on to the next one. So here I see 3, but they're all exactly the same. So it's not an atom because they're not individual. It is a molecule because I have atoms that are bonded together. It is not a compound because they are not different types of atoms. Okay, remember that's the difference between a molecule and compound. They're both made up of more than one type of element, but a molecules is more than one atom, period. A compound is more than one type of atom. All right, so then we have element. These are all a single element, so they're oxygen, so that's all O2s. Sorry, I should have done that. And then is it a mixture? No, it's only one type of molecule. Okay, so I'm going to write this one down. That is oxygen, which is O2. So that's quite lovely. All right. And then the bottom one here. The bottom one, we see that we have 2 hydrogens and an oxygen, 2 hydrogens and oxygen, 2 hydrogens and oxygen. So it's definitely a water molecule, right? And so if I go in and start looking, is it an atom? No, it has several different types of atoms there, and they're bonded together. Are they molecules? Yes, they are molecules. I've got more than one atom bonded together. It is also a compound because it is 2 different types of atoms bonded together. It is not an element because I have more than one type of element there. And it is not a mixture because they're all the same type of compound or molecule. This, of course, again, is H2O. Now, if you want, you can recognize that the first one being made of oxygen, water, and nitrogen, that's pretty close to the composition of air. Now, air does have other things in it, but these 3 are probably going to cover about 97 to 99% of whatever's in your air. Okay, even carbon dioxide is a very small amount of what's actually in the air. Most of it is nitrogen and oxygen, and then you can get a lot of water depending on how humid it is. Okay. This last one, I forgot to put yellow up there, but yellow is sulfur. All right. Okay. Using the idea of valence, electrons, and ions, explain why the atoms in the last molecule might form this way. So this is our oxygen, and oxygen is in the second column from the end, so not the last one, not the one with fluorine, it's the one right before that. So oxygen has 6 valence electrons. It's trying to get 2 more. So oxygen will be -2. The other 2 are hydrogen, which has 1 valence electron, so it's probably going to give that away. So each one of those electrons is going to be +1 because it's going to give away a negative electron. And so why would it form in this way? Well, the oxygen wants to take 2 electrons, and those 2 hydrogens are only happy to oblige. They're each going to give 1, or this could be an explanation. Each one will give 1 electron to the oxygen there. All right? So that was C. We just talked through that idea. All right? Now, which of the following is incorrect? Calcium hydride, sodium oxide, barium chloride, strontium oxide, magnesium oxide. So more than one of these could be incorrect. So what I'm going to do is I'm going to go through, we're going to look at each of these. So calcium is in the second row. It's number 20 underneath beryllium. And so it has 2 valence electrons, so it's going to try to be +2. It's going to try to get rid of those 2 electrons. Hydrogen is in the first column. It has 1 valence electron. It wants to try to give it away, so that's +1. If you look at this, hydrogen is trying to give away 1. Calcium's trying to give away 2. They're not going to give along very well. Hydrogen's going to be like, here, take my electron. And calcium will be like, no, you take my electrons. Hydrogen will say, no, you take, and it's going to turn out to be a big fight. They're not going to happen. Okay, calcium and hydrogen don't make very good friends. Okay, let's look at sodium oxide. So sodium is in the first column. That means it has 1 valence electron, so it's going to be +1. Oxygen is the second one from the end. Oxygen has 6 valence electrons, which means it's going to try to get 2, so -2. And if you look at this, if I have 1 sodium, that's going to be +1. And I have 2 oxygens. 2 oxygens means that it's going to be a -4. That ain't going to happen. The sodium is going to be like, here, take my electron. And oxygen is going to say, I want 4 electrons, hand them over. And the sodium is going to say, no, I can't do that many. So they're not going to get along very well. That's not going to happen. Moving along to barium chloride. Barium is in the second column. So it has 2 valence electrons. It's going to try to get rid of both of those, so that'll be a +2. Chlorine is in the next to last column there. It's with fluorine, right? Chlorine is number 17. So it has 7 valence electrons, which means it wants 1 more to complete its 8. So chlorine is going to be -1. So therefore it says BCl3. So 1B is going to give away 2 electrons, 3 chlorines. That's going to be 3 -1s that they want to gain. There's not that many electrons. There's only 2, my friend. So one of those chlorines is going to be very unhappy, and he's going to say, I'm out, and it's done. So therefore, that one's not going to work. Okay, next up, SR, strontium. Strontium is in the second column. It's number 38 below beryllium. So it has 2 valence electrons. It's going to try to get rid of those 2 electrons. That will make it +2. Oxygen is 2 columns from the left. It's number 8, right? Oxygen has 6 valence electrons, so it's going to try to steal 2 more. So if I had 1 strontium and 1 oxygen, they'd be happy. But 2 oxygens is going to try to take more electrons than we have. That ain't going to work. They're not going to be happy. Sorry, that one is out. Last of all, we have magnesium oxide. Magnesium is in that second column, so it wants to get rid of its 2 valence electrons. Oxygen is in the next to last again. We know oxygen wants -2. Again, MgO2. Oxygen's going to be too greedy. It's going to say, give me more electrons. I need 2, and the other one also needs 2. We need 4. And magnesium say, no, I don't have 4. Go away. And so that one's not going to work either. So, which of the following is incorrect? All of them are, because none of them balance the electrons properly. Every single one has either one that wants to give away too many electrons or one that wants to take too many electrons. So none of those will actually happen. All right, last page. We're doing great. So this last page, the ionic bonding activity, I'm going to leave you to try that on your own. Play around with it. Okay, this you can actually get to the link. You can either type it in or you can open this up in your Manage Back and you can just click on it. Okay, but I can help you answer some of these questions. All right. Number 11 says the first question shows Na plus 1 and S negative 2. Explain why. Well, sodium has one valence electron, so to have an outer shell that is full, it's going to try to give away one electron. So I'm going to write that down. Na has one valence electron, wants to give it away. All right. The S, if we look at S, S is in the second column from the right under the oxygen. S is 16. So S has 6 valence electrons. So it wants to steal 2 so that it can have 8 in the outside so that it can be full. All right, now that of course leads into question B, which is why does your response in part A lead to needing 2 sodiums and only 1 sulfur? Well, you need 2 sodiums so that you can give away 2 electrons because each one only wants to give away 1, so that the sulfur, the S, will be full and when it gets its 2 electrons so that it can be happy and smiley face. All right, lovely. So now we're going to have a look at the last couple of questions here. These are some challenges. So you don't have to do these, but let's see what we can figure out. So a chemist mixes 2 aqueous solutions together and notices that a solid substance, do you remember what that's called? The solid substance? That was a precipitate. I can say it. Precipitate. I can't spell it. Precipitate, okay. One of the solutions is sodium fluoride, NaF, and the second is calcium nitrate. So what is a possible formula for the solid substance formed? So I'm going to write that out. I'm going to have NaF, okay. Looking at my table of elements, I can see that sodium is a +1 and fluorine is a -1, okay. And then I have calcium nitrate, CaNO3 2, all right. And one of the things I notice is that Ca is a +2, which means that NO3 must be a -1 because I have 2 of them there. So that's one of those polyatomic ions, which means it stays grouped that way, all right. And so I need 2 of those -1s to match up with the +2 of the calcium. Now, because each of these has 2 elements, this is likely going to be a double replacement, and so the 2 negatives are going to switch. Luckily, they're both -1, so what this is going to do is that the NaF will become NaNO3, and that will match up nicely because they're both -1. And then over on the other side, I'm going to have Ca, which is 2+, and then F, which is only -1. So I'm actually going to need 2 fluorines there because the calcium was +2. I need 2 fluorines so that I can take 2 electrons. Now, that's not quite balanced, right? Because I just added in a second fluorine, and I did have 2 nitrates over here. So I need to have 2 of those. So I'm going to put a 2 in front of this so that I have 2 nitrates. That also is going to give me 2 sodiums, which is okay because I needed to have 2 fluorines anyway. So 2 sodiums, 2 fluorines. Now I have 2 sodiums, 2 sodiums, 2 fluorines, 2 fluorines, 1 calcium, and 2 nitrates, 2 nitrates. All right, there we go. What's a possible formula for the solid substance? Well, either it's this NaNO3 or it's the calcium fluoride. Now, if you don't know anything else at this point, then we would accept either one of those. Okay? At some point in your chemistry career, you may learn how to determine which one of those is a solid and which one is not. But right now, we'll leave it the way it is. All right? Very nice. Very nice. Number 13. One form of carbon has 8 neutrons. It is often called carbon-14. Why do you think it's called carbon-14? Well, if you look up carbon in the periodic table, Carbon has 6 protons. Now, it just said it had 8 neutrons. Where do you think the 14 came from? Well, hopefully you're saying, Mitabawada, 6 plus 8 is 14. And I would say you are absolutely correct. Carbon-14 is called carbon-14 because that is the mass, the atomic mass, or sometimes we call it the nucleon number. Okay? So that is the number of protons and neutrons that it has. There's also other types like carbon-12 and carbon-13. Those are all different isotopes. Now here, this is an interesting question. Carbon-14 is not very stable. There are too many neutrons, right? You might notice that most of the smaller atoms have the same number of protons and neutrons. They don't have to. In fact, the bigger that your atom gets, the more neutrons it needs. But most of the smaller ones are fairly well balanced. So over time, there will be what's called beta decay. This means that one of the neutrons will turn into a proton and shoot out a negative beta particle. Now this is kind of crazy. So what it's saying is a neutron is going to turn into a proton and an electron. Now that should be okay because you recognize that a proton is positive and an electron is negative, so they still add up to be neutral like the neutron was. But this is going to change my atom, right? Because I had 6 protons and 8 neutrons, but now one of those neutrons is turning into a proton. And so if that happens, I'm now going to have 7 protons, and I'm going to have 7 neutrons. Now, if I look up 7 protons in my table of elements, I see that 7 is nitrogen. And so this would be nitrogen 14 because it has 14 total nucleons, 14 protons and neutrons total. All right, there you go. So yeah, that's definitely something new, but we can go ahead and we can recognize that we're changing protons and neutrons, and we can look that new element up in our table of elements. All right? So here we go. We got 2 left. Number 15 I'm not going to do because this is just that activity. Go try it out. Play around with it a little bit. See if you can get the gold or even, oh, the platinum. All right? So then we have, consider the compounds sodium chloride and magnesium oxide. One of these has a melting point of 801, and the other has a melting point of 2,852. Using your understanding of ionic bonds and melting, which compound has the higher melting point? All right, well, Na is a +1, and Cl is a -1. Right? I can get that from looking at my table of elements. If you're having a hard time with that, you probably shouldn't be doing the challenge problems. Mg, I now look up. Mg is a +2, and oxygen is a -2. All right? Now, the question, we have one with a melting point of 801, which is already a pretty high melting point, but the other one has a melting point of 2,800 Celsius. That is nuts. That's crazy, right? That's really, really hot. Now, which is which? Well, remember we talked about in class the idea of the ionic lattice, right? With the plus and the minus and the plus and the minus, right? And then you have a minus and then plus. The reason why this ionic lattice, this ionic bond forms is because of the charges, right? It's the attraction between those positives and negatives. Because that attraction is so strong, it makes it so that it's difficult to melt it, right? It's difficult to break those bonds. Now, which has stronger bonds? A +1 and a -1, or a +2 and a -2? Which one of those do you think would be more strongly pulled together? Well, hopefully you're recognizing that having a larger charge, a larger positive and a larger negative, would lead to having a stronger attractive force. Just like 2 objects with bigger mass will have stronger gravity, two objects with larger charge will have a stronger electrical force. So there will be a stronger bond there. So therefore, we would say that the one that has the +2, -2, that one is going to have stronger bonds, which means it's going to be harder to break those or weaken those. And so therefore, it will have the higher melting point. So therefore, magnesium oxide will have the higher melting point because it has ions with larger charges. Okay? Now, the sodium, notice we did talk, I actually mentioned this in class. I said sodium chloride has a melting point of about 800 Celsius. And so you might have been able to figure it from that as well, but I do want you to think about the fact that larger charges mean stronger forces. All right? That's the end. We've worked through this whole worksheet. I hope that's helpful for you, and I will see you next time.